E-Maths class, Fatima Convent High School, myself, Dipali, Chapter 4, Carbon and its Compounds. In this session, we are going to understand about chemical properties of carbon. After knowing the physical properties and the nomenclature of carbon compounds, let us talk about its physical properties. In this section, we will be studying about some of the chemical properties of carbon compounds. Since most of the fuel we use are either carbon and its compounds, we shall first study combustion, because how carbon burns and what are the effects of carbon burning. So carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with the release of heat and light. Most of the carbon compounds also release a large amount of heat and light on burning. These are the oxidation nature that you learnt about in first chapter. So C plus O2 gives CO2, and heat and light is also generated during this reaction. Then methane CH4 plus O2 gives CO2 plus H2O. Plus heat and light. Same way, this is ethanol. CH3CH2OH plus O2 gives CO2 plus H2O plus heat and light. So carbon plus oxygen in any form gives carbon and dioxide plus water plus heat and light. Now, this activity needs teacher's assistance. Take some carbon compounds, naphthalene, camphor, alcohol, which are available around you, one by one on a spatula, and burn them. Observe the nature of the flame and note whether smoke is produced. Place a metal plate above the flame. In this, a deposit of plate is case of any of the compound. You will see there will be some deposition of a sooty flame or a black substance over the flame. Now light a Bunsen burner and adjust the air hole at the base to a different type of flame presence of smoke. When do you see a yellow or a sooty flame, and when do you get a blue flame? Now the saturated carbons will generally give a clean flame, that is, which are not having any double or triple bond, while unsaturated carbon compounds will give a yellow flame with lots of black smoke. This results in a sooty deposit on the metal plate in the activity. So do you understand? Out of this, most of them are sooty in nature because they have unsaturated carbon present in them. However, limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. The gas kerosene stove used at home have inlets for air so that sufficient oxygen-rich mixture is burnt to give a clean blue flame. If you don't see a clean blue flame when you burn or light your gas stove, and a black sooty deposit is observed on the vessel, means the oxygen supply is not good. If you observe the bottom of the cooking vessel getting blackened, it means the air holes are blocked and the fuel is getting wasted. Fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. This combustion results in the formation of oxides of sulfur and nitrogen, which are major pollutants in the air. So, this is the effect of combustion on carbon. Now, why do substances burn with or without a flame? Very interesting to know. Have you ever observed either a coal or a wood fire? If not, the next time you get a chance, take close note of what happens when the wood or coal starts to burn. You have seen above that a candle or LPG in the gas stove burns with a flame. However, you will observe the coal or a charcoal in an angithi, that is a sigri, sometimes just glows red and gives out heat without flame. This is because a flame is only produced when the gaseous substance burns. When wood or charcoal is ignited, the volatile substance present vaporizes and burns with a flame in the beginning. A luminous flame is seen when the atoms of gaseous substance are heated and start to glow. The color produced by each element is a characteristic property of that element. Try and heat a copper wire in the flame of a stove and observe you get a green colored flame. You have seen that incomplete combustion gives soot, which is carbon. On this basis, we will have attribute the yellow color of the flame to the candle flame. This is what you understand by how fuels burn and what sort of effect it causes. How were the coal and petroleum formed? Coal and petroleum have been formed from biomass which have been subjected to various biological and geological processes. Coal is the remains of trees, ferns, and other plants that lived millions of years ago. They were crushed into earth, prepared by earthquakes or volcanic eruptions. They were pressed down by layers of rocks and earth. They slowly decayed into coal. This is solid terrestrial deposition of organic matters, whereas oil and gas are the remains of millions of tiny plants and animals that lived in sea, that is petroleum. When they died, their bodies sank to the bottom of the seabed and were covered by silt. Bacteria attacked the dead remains, turning them into oil and gas under the high pressure they were being subjected to. Meanwhile, the silt was slowly compressed into rocks. The oil and gas seeped into the porous parts of the rocks and got trapped like water in a sponge. Can you guess why coal and petroleum are called fossil fuels now? Because they are formed by deposition of various organic substances. Now let us see the next property, oxidation. Take about 3 ml of ethanol in a test tube and warm it gently in water bath, otherwise it might catch fire. Add 5% solution of alkaline potassium permanganate, that is KMnO4, drop by drop to this solution. Does the color of potassium permanganate persist when it is added initially? Why does the color of potassium permanganate not disappear when excess is added? You have learned about oxidation reaction in chapter 1. Carbon compounds can be easily oxidized on combustion. In addition to this complete oxidation, we have reactions in which alcohols are converted to carboxylic acid. Because when ethanol is added to potassium permanganate or potassium permanganate is added to ethanol, carboxylic acid is formed due to oxidation, and because of that the color initially persists but later on it disappears. So when CH3CH2OH, alkaline KMnO4 plus heat or acidified K2Cr2O7 plus heat is given, you get ethanoic acid. We see that some substances are capable of adding oxygen to others. These substances are known as oxidizing agent. Alkaline potassium permanganate or acidified potassium dichromate are oxidized alcohols to acid, that is adding oxygen to starting material, and hence they are known as oxidizing agents. Now addition reaction. Carbon undergoes or carbon compounds easily undergoes addition reaction. In this, unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbons. So if you see here a double bond and a palladium or a nickel catalyst, H2 is replaced by breaking this double bond and adding one H. Catalysts are substances that cause a reaction to occur or proceed at a different rate without the reaction itself being affected. So this is the definition for catalyst. This reaction is commonly used in hydrogenation of vegetable oil using a nickel catalyst. Vegetable oil generally has long unsaturated carbon chain while animal fat has saturated carbon chain. So you must have seen advertisements stating that every vegetable oil are healthy. Animal fats generally contain saturated fatty acids which are said to be harmful to the health. Oil contains unsaturated fatty acids should be chosen for cooking. This is the reason why you should be very selective. Substitution reaction. Here one hydrogen or one atom will be replaced by the other element. So saturated hydrocarbons are fairly inreactive and inert in presence of other most reagents. However, in the presence of sunlight, chlorine is added to hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atom one by one. It is called as substitution reaction because one type of atom or a group of atoms takes the place of another. A number of products are usually formed with the higher homologous of alkanes. So here CH4, if you represent it this way, then with Cl2 gives here H and Cl from this will be liberated and will give us H, C, H, H and Cl, that is plus 1 HCl. So that is CH3Cl, which is chloromethane. This is how the chemical reactions of carbon are, or chemical properties of carbon are: combustion, then we have oxidation, addition reaction and substitution reaction. In next chapter we are going to study about ethanol and ethanoic acid in detail. Thank you.